All right. Least common multiples, lesson 4.7. Here's the deal. What are multiples? What is multiples? What are multiples, Emily?
Numbers are like multiple. Like you can multiply them by.
Right, so what are the multiples of 2? 2, 1?
No. 1.
No, well, that is not a multiple of 2. What are the multiples of 2?
2, 4, 6, 8, 10.
What are the multiples of 5, Michael? What are the multiples of 12, Ellie? Multiples of 12. Right, good. Multiples of 20, Dylan?
20, 40, 60.
Okay, good. Multiples means that you could multiply that number by anything, and that will be a multiple of that. So multiples of 6. Is 36 a multiple of 6?
Yes.
Why? Because 6 times 6 is 36. Is 42 a multiple of 6?
Yes.
Yes. So here's the deal. Multiples of 10 are 10, 20, 30, 40. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32. Right? Finding the least common multiple between two numbers, there's 2 ways to do that. The least common multiple. What does least mean? What does least mean? Oh, I need more help than this. What does least mean, Jonathan? Lowest or smallest. What does common mean? Sladen? No. What does common mean? Yeah.
Most often.
Or same, right? Least common multiple means the smallest same. If I have something in common with Caleb, that means that we have something that is the same. Agreed? Smallest same multiple. That's what least common multiple means. If I said, what is the least common multiple of 20 and 8? One way of doing this would be to list all the multiples. Just list multiples until you find the smallest one that is in both lists. 20, 40, 60, 80. 8 is 8, 16, 24, 32, 40. Wow, the smallest same number that's in both lists is 40. The least common multiple of 20 and 8 is 40. Do you see what I'm talking about?
Yes.
You make a list. I'll do another one for you. What is the LCM of, 16 and 40? Let's look. Do you know the answer? Is that what you're saying? You know the answer? What's the answer?
2.
No.
Or 1.
No. Least common multiple. What are the multiples of 16? 16, 32, 48, 64, 80, 40, 80, 120, 160. I'm done because I already have the multiple. Does that make sense? You need to know the difference between LCM and GCF. What's GCFs mean? Greatest common factor. What are factors? Numbers that go into another number evenly. Multiples are when you multiply that number by whatever whole number, right? Multiples. You guys try one. Find for me the least common multiple of these numbers for me. Of 9 and 30. Find me the least common multiples of 9 and 30. All right, here we go. Listing the multiples. What are the multiples of 9? Jared?
9, 18, 27, 36, 45, 54, 63, 72, 81, 88.
Agreed? Here's the trick. Okay, that was a lot for the 9s. It took you a while to get there, right? Wasn't that's kind of a lot of work? Here's the trick. If the bigger number is easier, start with the bigger number and go, okay, the first multiple of 30 is, what's 30 times 1? 30. Does 9 go into 30 evenly? No. 60. Does 9 go into 60 evenly? No. 90. Does 9 go into 90 evenly?
Yes.
Make sense?
Yes.
Make sense?
Yes.
Here's the deal. That way is a very effective way of doing it. The problem with it is that what happens when you get big numbers? What if I gave you numbers like, 24 and, 60? All of a sudden now, oh my goodness gracious. I mean, do you really want to start rattling off the multiples of 24, 24, 48, and then you're like, okay, then there's 72, and then, oh my goodness, and then, you see what I'm saying? Like it gets ugly. Agreed? You see what I'm talking about? When you get big ugly ones, there's another method that you use. It's called prime factorization. Have you ever done prime factorization before?
No.
No, right? How many of you have done prime factorization before? Oh, we need to come back into class at lunchtime, huh?
No.
Seems like we might, because when I asked if you've done prime factorization, I got like 3 hands. And that was like yesterday and the day before. What is prime factorization again? What is it? Dylan, what is it? You break
down the
number
and find
and multiply it by its prime factors. That's prime factorization, right? Same thing. The numbers 24. Well, let's do this first. If we're going to do it the other way, 24 and 60, all of a sudden we have to go 24, 48, 72, 96. First of all, you guys probably wouldn't be able to do it like this. 120. Right, it is 120, but you can see that. But all of a sudden, I mean, it would have taken you a while to do that. Agreed? 60, 120. There we have it. Let's do it my way. Let's do it with the prime factorization way when you have big numbers. What is the prime factors of 24? 8 and 3. And now 8. 8's the good one. What's 8? 2 times 2 times 2. Right? It's just 2 times 2 times 2. Remember that. 8's an easy one. 2 times 2 times 2. It is 2 times 4, but then the 4 breaks down to 2 times 2 anyway, right? So 24 is 2 times 2 times 2 times 3. Agreed? 60 is 6 and 10, 2 and 3, 2 and 5. Okay, so 60 is 2 times 2 times 3 times 5. Here's how you use prime factorization to find the least common multiple. Okay? You have to look and see, what are the prime factors? What are just the total overall prime factors of 24 and 60? Well, there's 2s, there's 3s. What else? There's 2s, 3s, and 5s. You see that? There's 2s, 3s, and 5s. This is what you do. You find whichever of those numbers has the most 2s. Which one of those has the most 2s in it? 24. You circle those 2s. Which one has the most 3s in it? They're tied. It's tied. So it doesn't matter which one you choose. You're just going to choose one. I could have chosen this one. It doesn't matter. Which one has the most 5s? The bottom one does, right? Once you've done that, you simply multiply all those numbers together, and it will give you your answer. What is 2 times 2? 4. What is 4 times 2? 8. What is 8 times 5? 40. What is 40 times 3? 120. We had already established that it was 120 up here, right? But the other way is just as effective, if not more effective, when you're dealing with big numbers, right? If I ask you to do what is the least common multiple of 6 and 9, which method should you use to find the least common multiple of 6 and 9? Just listing them, right? Just list the factors. 6, 12, 18, 9, 18. You're done, right? You wouldn't want to do the prime factorization. It takes too long. But if I said 48 and 70, all of a sudden like, 48 and 70. Let's see. 48, 96. What's next, guys? 144, 196. Am I even there yet? No. Right? Okay, so then what method should you use if I give you big, ugly ones like that? Prime factorization. What's the prime factorization of 48? 6 and 8, which is 2 and 3, and 2, 2, 2, right? So 48 is 2 times 2 times 2 times 2 times 3, right? Okay. 70 is 7 and 10, 2 and 5. Okay, so 70 is 2 times 5 times 7. Agreed? What do I have? What numbers are present here? 2s, 3s, 5s, and 7s, right? Which one has the most 2s? Which one has the most 3s? Which one has the most 5s? Which one has the most 7s? 2 times 2 times 2 times 2 is 16. 16 times 3 is 48. 48 times 5 is 240. And then 240 times 7, 1,680 is the answer. Now I have a question. How would you have liked to try and list the factors all the way up to 1,680?
Awesome.
It would have taken you forever. I mean, like, it would take up a whole page. Do you agree? So, isn't doing the prime factorization a lot easier when you're dealing with big numbers? Yes. So, I'm going to give you guys a few to try. Okay? I'm going to give you a few of them to try. Let's do, well, I'm going to show you one more practice one. What happens if I do this? 8. And 15. The least common multiple of all three. What am I asking for? The least common multiple of all three. What am I saying? What am I asking? The smallest same multiple in what? In all three. You see what I'm talking about? The smallest same multiple in all three. Okay? So, I could list them. 8. These are kind of small numbers, right? They're kind of small. So we could do it that way. 8 is what? 8, 16, 24, 32, 40. Now here's the deal. How do I know if I'm done at 40 or not? Does 15 go into 40?
No.
So you know that, does 15 go into any of these actually? No. So then you know you're not done, right? 40. So then after 40, it would be 48, 54, 56, thank you, and 64, 72, 80. Does 15 go into any of those yet? Oh my goodness. So then do you see where this is still going to be humongous? I mean, like, so what should we do at this point? Whenever you have 3, my strong suggestion is that you do prime factorization. What is the prime factors of 8? 2, 2, 2. So 8 is 2 times 2 times 2. 12 is 2 and 6, and which is 2 and 3. 12 is 2 times 2 times 3. Yes? Are you done talking, Donovan? 15 is 3 and 5. What do I have? 2s, 3s, and 5s. Which one has the most 2s? Which one has the most 3s? It's tied. So what do I do? Just choose one of them. Which one has the most 5s? Okay. What is 2 times 2 times 2? 8. 8 times 3? 24. What is 24 times 5? 120. My answer is 120. Does that make sense? It's a lot easier to use the prime factorization because then you know there's an end in sight. You can actually find the answer. You know that you have a little bit of work to do, but you're going to find the answer. The other way, you're kind of just going, and you don't even know where to stop. You know what I'm saying? You don't even know where to stop. Okay, now you guys try one. Try 12 and 15. I don't care what method you use. I really don't. Find me the least common multiple of 12 and 15. To do. Did anybody list them? You listed them? Could list them. What method did you choose? Did you guys use prime factorization? It's easier, right? You could have listed them. Listing them would be 12. I mean, you have to know the multiples pretty good. 12, 24, 36, 48, 60, 72. See, you're not even quite sure when to end here, but okay, whatever. 15 is 15, 30, 45, 60. Oh, there they are. Right? So you got, Gina? Did you get that? What'd you get? 120?
I saw yours.
So you got?
I just did the multiples of 15 until I recognized the multiple of 12.
Right, exactly. That's the shortcut, right? Do the multiples of 15 until you recognize a multiple of the other number, which happened to be 12. Perfect. The other way of doing it is the prime factorization way, which is 12. What's the prime factorization of 12? 2 and 6, which is 2 and 3. So 12 is 2 times 3. What's the prime factors of 15? 3 and 5, right? 15 is 3 times 5. What numbers do I have? 2, 3, and 5. Which one has the most 2s?
12.
Which one has the most 3s? We're tied. Which one has the most 5s? What is 2 times 2? What is 2 times 2? 4. What is 4 times 3? 12. What is 12 times 5? Same stinking answer, right? Right? Same answer?
Yep.
I saw you on us.
Try another one. Try 4, 7, and 20. What method did you choose? Okay. Could you have listed them? Could have. It would take a long time, right? 4, 8, 16, 12, 16. It would take a long time. Whenever you have 3 of them, do the prime factorization. What's the prime factorization of 4? 2 and 2. So 4 is 2 times 2. 7. What's the prime factorization of 7?
7.
It's just 7. Exactly. Very nice. 7 is 7. What's the prime factorization of 20? 2 and 10. 2 and 5. So 20 is 2 times 2 times 5. What numbers do I have? 2s, 5s, and 7s. Okay. Which one has the most 2s? They're tied. Okay. Just choose one of them then. 7s is here. 5s is here. What is 2 times 2? 4. 4 times, well, should you do 4 times 7 or 4 times 5? I would do 4 times 5 because 4 times 5 is easy. It's 20, right? 20 times 7 is 140. How many of you got 140 as the answer? Good. You see how easy it is to use prime factorization to find the least common multiple? The issue is remembering how to do this a month from now, right? Remembering how to do this next year, that sort of thing. Anyway, I think you have enough to do your homework. Honestly, people, I'll tell you this. Like for numbers 6 through 17, it says to use listing. I don't care how you do it. I really don't. I really don't care which method you use on any of these as to finding the don't interrupt. I really don't care what method you use to find them. If you can even do it in your head, that's fine. Here's the issue. If you do it in your head, you might make a mistake. It may not be the least common multiple. It might just be a multiple, right? A lot of times people go, the numbers 10 and 20. They might go, okay, the least common multiple is 40. Just really quick, you go, oh, it's 40. No, it's not. What's the least common multiple of 10 and 20? Not 2, 20. Right? Least common multiple. We're talking. You guys are going to get this confused. The greatest common factor and least common multiple. I know it. Tomorrow, when we take our quiz, we're going to find out which of you gets this. Your homework.